Welcome to the next video. In the previous video, we have seen the implicit formulation of the density-based numerical method. In the implicit way of formulating the non-linearized equation into linearized fashion, we understood that in this procedure, uh, the neighboring values of the cells are considered along with the unknown values, and those are solved, which indicates that this formulation is dependent on the other values as well. All right, in order to get the actual values for the respected unknowns, that is pressure, velocity and temperature, if we are considering a coupled continuity, momentum and energy equation. All right, now if we are moving with the coupled explicit formulation, what is happening, we will just see it is quite opposite of it, to be in a simple straight forward way. If you choose the explicit option of the density based solver, and each equation in the coupled set of governing equation is linearized explicitly. Okay, I mentioned over here that we are linearizing implicitly, now we are linearizing explicitly. Okay, as in the implicit option, this too will result in a system of equations with n equations for each cell in the domain, and likewise all dependent variables in a set will be updated at once. So what did I mention to you, that if we are considering the implicit way, we will be having the n equations depending on the we will be having the n number of variables depending on the n number of equations. For example, we have this 3 equations, we will be having the associated unknowns for these 3 equations, right? Same thing is happening over here. However, this system of equations, I mentioned to you that this system of equations what we have attained after linearizing, right, is explicit in the unknown dependent variables. We will see what is it. For example, the x momentum equation is written such that the updated x velocity is a function of existing value only, right? So what's happening is, I mentioned you in the implicit way, we are considering the neighboring values and we are trying to find out the existing cell value. But in this case, we are not doing that. It is independent of the neighboring values. It is just considering itself. Okay, from the updated values what we have considered in the beginning, it is solving considering those values, and it is just solving the respected cell for the governing equations and getting a respected updated field value. Now, because of this reason, a linear equation solver is not needed. Instead, the solution is updated using the multi-stage solver. So in the previous case, we have used this solvers, the AMG solver, and we have used ILU scheme actually, but in this case, those are not required for us. And here you have the additional option of employing a full approximation storage, that is FAS multi-grid scheme, to accelerate the multi-stage solver. Now if you want to accelerate the solver, we have an additional option. This is a kind of additional tool, what we can say, which is present with us. Now what is the summary of this one? In summary, the density based explicit approach solves for all variables one cell at a time, right? Now you can see the major difference here. It solves for all the variables in all cells at the same time, but here it is solving one cell at a time. That is what is the difference between these two, and I request you to read them and try to find about them in more detail in other resources. Of course, we are just discussing very cut to cut, but there is a lot of background for these as well, which I cannot spare in this particular videos or in this particular course. I'm just trying to cover up what is mentioned in the manual, because a brief discussion of this will help us understand the reason for selecting these options when we are solving the respected application flow, right? With this knowledge, let us move to the next video and see what we can work with ANSYS Fluent.